Okay, so today we're going to continue talking about the higher education system and its impact on economic mobility in the US. And just to remind you where we left off in the past couple of lectures, we were talking about three elements that are critical for understanding the role of higher education in economic mobility: the parental income distribution of the students at each college in America, students' earnings outcomes, how well students do after graduation, and then the third piece, which is what we're going to start with today, is the causal effects of colleges. What fraction of the difference in earnings that we see across colleges that we talked about 2 lectures ago before Tim Rennick's guest lecture, what fraction of those differences are due to causal effects? Okay, so I'm going to pick up with that third element today and then put the 3 pieces together to talk about how we can increase the impacts of higher education and colleges on upward mobility and helping low-income kids achieve better outcomes. Okay, so as I was just saying, the third factor needed to assess the effects of higher education system on mobility is the fraction of the earnings variation across colleges that is due to causal effects as opposed to selection. So first question, why does this matter? Just to be clear about why we're focusing on this. So take an extreme example. Suppose the differences in earnings outcomes between students at Harvard and students at some other college that we've seen in the data were driven purely by the selection of who gets in. So as professors here, we hope that there's some value added of attending Harvard, that there's some causal effect of attending this college, but we're also fully cognizant of the fact that the set of students who come to Harvard are a very highly selected group of people, and they presumably would have done quite well even if they had gone to college somewhere else. And so if you take the extreme scenario where you imagine there's actually no causal treatment effect of attending Harvard versus another university, then you can then ask, suppose the differences between students who attend Harvard and other colleges are purely due to selection, right? And so now imagine we think about policies as we're going to do in today's lecture. Suppose we think about policies that change which colleges students attend. So we try to reduce segregation across colleges by changing admissions rules, which we'll talk about in a little bit more detail in a second. If, in this hypothetical extreme case, the colleges actually have no causal treatment effects, then that sort of reallocation of efforts to reduce segregation across colleges would have no impact on economic mobility, right? If students are going to do just as well, no matter which college they attend, and the only differences we're seeing in earnings across colleges are due to pure selection, then changes in admissions policies, trying to change the nature of the higher ed system, is not actually going to achieve anything. But if, in contrast, as we think is plausible, at least part of the difference in earnings across colleges reflects causal effects, that is, going to Harvard actually changes your earnings relative to going to, say, your local state school or some other place, then changes in admissions policies could potentially have a very big impact on mobility. Okay, so that's why it's critical to figure out, if we see Harvard students earning 30% more on average than students who go to their home state school, how much of that 30% gap is due to the causal effect of attending Harvard versus pure selection? And so that's what we're going to turn to first in this lecture. So with any case where you're trying to estimate causal effects, I think a good way to think about it is first step back and ask, what is the ideal experiment that you would run in order to estimate the causal effect of interest? And so in this particular case, ideally what you would do is randomly assign kids to all of the different colleges in the US and compare their earnings at age 30. So as I'm sure you can all appreciate, you presumably would not like a random admissions policy at Harvard or any other college. And so lacking such an experiment, you have to figure out some way to set up a quasi-experimental design that effectively allocates comparable students to different colleges. So we need to find some source of variation such that we can compare students at Harvard or students at College A to College B in a way that ensures comparability, right? We're not going to be able to randomly assign students to those two places, which would guarantee comparability. But rather, can we find some way to find a source of variation in the data such that you have quasi-random allocation of students across colleges? Now, this is a pretty challenging problem, not just because it's hard to find that sort of random variation, but also because if you think about it, you've got 3,000 colleges in the US, you're trying to estimate, in some sense, 3,000 different causal effects. So ideally, you would have 3,000 different experiments where you're comparing college A to college B to college C, et cetera, et cetera. So there are lots of different parameters you're trying to estimate. And so that's a quite challenging thing to do. So what I'm going to do here is focus on a recent paper that illustrates how people are trying to estimate the college's causal effects with one very specific case. So it's this paper by Seth Zimmerman in which he estimates the causal effects of attending one particular university, Florida International University, a public university in Florida, by exploiting admissions cutoffs. And I'm going to go into some detail on this because the methodology that he uses is useful not just in this setting, but more generally, as you'll see. And so in particular, your second empirical project makes extensive use of these regression discontinuity methods, which I'm going to talk about here and which you'll talk about in more detail in section. Okay, so what Zimmerman does, it's really very simple. It's to compare students just above and just below the state level GPA cutoff for admission to the Florida State University system. So the way this works, it's summarized in this table. So basically, you know, at Harvard and other elite colleges, there's a tremendous amount of effort put into the admissions process where you have a committee that's reviewing applications and looking at many different things and so forth. At large state schools, both because of the volume of applications, you're getting tens of thousands of applications, and because of limited resources, it's very difficult to have that, you know, careful screening of every single file using qualitative methods. So inevitably, what people end up using is some quantitative screens, basically some cutoffs that you have to meet to get into the university, or at least to have your application considered. They don't go strictly by these cutoffs, but that's at least a major starting point. And so you can see the way this works, they have this kind of sliding scale where it depends upon your SAT score and then GPA that you need in order to get into Florida International University, or basically get into the Florida state system. Florida International University is, think of it as like the lowest ranked four-year state college in Florida. And so, you know, just reading across the rows here. So for instance, if you had an SAT score of 1140, you have to have a GPA of at least 2.0 in order to get in. If you had an SAT score down at 970, then you have to have a GPA, or below 970, you have to have a GPA of at least 3.0 in order to get in. So they're basically looking for some combination of reasonably high SAT scores and GPA in order to get in. So in particular, there are lots of students who are going to have SAT scores that are, you know, in like the 970 range in terms of what he's focusing on here. And so then think about the student who has a GPA of 2.99. That student, by this rule, is basically not going to get in. And a student with a GPA of 3.01 who is going to get in, that's the type of variation that he's going to exploit to identify the causal effect of attending Florida International University. So just to see how this plays out in the data, so the horizontal axis, let's focus on the graph on the left first. The horizontal axis here is how far away your GPA is from the cutoff that's relevant for you given your SAT score. So if your SAT score was below 970, then 0 corresponds to 3.0. If your SAT score was at 1120 or whatever the highest value was on the previous slide, then it corresponds to a GPA of 2.2. So we're basically calling 0 the point at which you cross that threshold for getting in. And then the vertical axis is plotting what fraction of kids get admitted to FIU. And so you can see that there's a big jump in adherence with the rule right at the cutoff. Now, to be clear, it doesn't go from 0 to 100%. That reflects the fact that they're not mechanically following this rule. They're not literally just saying, this is the only thing that matters. They have some additional review that they do, and if you were just below the cutoff and you maybe came from a certain school or had certain background, extracurriculars, et cetera, on your file, you might still get in. But you can see that that cutoff plays a big role, right? Your odds of getting into FIU are 23 percentage points higher if your GPA happens to be 3.01 rather than 2.99, okay? And so that sharp jump is going to be really useful for identification of the causal effect of attending FIU, as you will see in a second. Okay, so that's the admissions probability on the left. Now, what we actually care about is not just getting in, but actually attending, right? And so getting in is a prerequisite for attending, obviously, but it doesn't mean that everybody who gets in is actually going to attend. So what he's showing on the right is that it doesn't just affect the admissions margin, it actually affects who shows up at FIU. Okay, so the people on the right of the cutoff are 10 percentage points more likely to attend FIU than the people just to the left of the cutoff. Okay, so what does Zimmerman do? As I was saying, he compares students just above and just below the state level GPA cutoff for admission to the system. And so the way to think about this in analogy to the experiment is that those with a GPA just above the cutoff, you can think of them as the treatment group in an experiment. They got the FIU treatment. And you can think of those just below the GPA cutoff as the control group, the people who did not get into FIU, okay? So the control group, whenever you define a treatment and a control group, we're clear on what's happening with the treatment group here, right? They're attending this particular university. What is going on with the control group? So when we estimate a causal effect, we need to know what the what treatment the control is getting in some sense. And so the control group, in this case, he shows in the data, typically ends up attending a 2-year community college in Florida rather than FIU. So you should think of the experiment here as attending a 4-year state university rather than a 2-year community college, not attending FIU versus not going to college at all. Because the people who didn't get in, they're going to tend to go to kind of their next best option, which is typically going to be a 2-year community college. Okay, so what is the logic of this method? Basically, what we're going to do is compare the earnings outcomes of the kids who ended up just above the cutoff versus the earnings outcomes of the kids who ended up just below the cutoff. So basically, we're going to compare the earnings of kids who had a GPA of 3.01 and applied to FIU versus the kids who had a GPA of 2.99 and see how well they do. So as I've discussed before, anytime you're running a quasi-experiment rather than true experiment, you need to make an assumption that we call an identification assumption that allows you to estimate causal effects. Basically, you need to make an assumption that makes your quasi-experiment as good as an experiment. And so what is the key identification assumption for regression discontinuity? It is that all other determinants of earnings are balanced on either side of the cutoff. So by balanced, I mean comparability. Remember when I talked about how experiments work in an early lecture? Basically, the idea is that you want to be comparing apples to apples, right? You want to make sure that the people in the control group are comparable to the people in the treatment group. An experiment guarantees that by randomization. Here, we're going to make an assumption that the people who happen to have a GPA of 2.99 are pretty similar to the people who happen to have a GPA of 3.01. So suppose we make that assumption, okay, that those two sets of people are comparable in terms of their overall merit. It's just by chance you ended up with a GPA that was a bit lower than someone else. It seems like a plausible assumption. Okay, if we make that assumption, then any jump in earnings at the threshold when we cross from 2.99 to 3.01 has to be due to the discrete jump in the chance of attending FIU instead of the community college. So we can basically attribute it to the causal effect of attending FIU instead of the community college, right? And so, you might ask, like, is this a reasonable assumption or not? I think it's a plausible assumption. We don't know for sure if it holds, but it's a plausible assumption because the admissions threshold was not widely publicized. Nobody knew, you could, in principle, look up that information that I had put up in that table, but I don't think this was really like something students were paying a lot of attention to. And so given that it's not publicized, it's hard to imagine that the people who were applying with the GPA just below versus just above the cutoff are dramatically different from each other. In contrast, suppose the cutoffs were actually very well publicized, then you might worry that the students just above the cutoff would be different from those just below the cutoff, because there's a strong incentive if you want to get into the university to try to do something to get your GPA just over 3.0, right? And so the students who manage to do that, maybe they put in a little bit of extra effort, or they came from a certain school where their guidance counselor helped them figure out how to get over the threshold. We call that in statistics manipulation of the running variable that is creating this regression discontinuity, and that would pose a problem here. It would ruin the experiment. But we think that's probably not likely to be going on here. Now, anytime you do one of these regression discontinuities, and you'll see this in your empirical project, you want to make an assumption that seems reasonable ex ante, but then you also want to try to evaluate the validity of the assumption you're making as best you can. And in this case, the way you do that is by making sure the observable characteristics that you can see in the data, students' characteristics, look relatively similar on both sides of the cutoff. So let me give you an example. So here we're plotting the fraction of students who are black around the same admissions cutoff, the GPA cutoff. And what we see here is that that number hovers around 30%, both for the students who are just below the cutoff and just above the cutoff. That is, on this dimension, the students just below the cutoff in terms of racial mix look relatively comparable to the students just above the cutoff. So that's encouraging. If we saw a huge difference here on the left and the right, that would show us that we don't have a valid experiment, basically, right? We wouldn't be comparing similar people on the left and the right. Another example, you can look at gender. So gender also looks relatively similar. The fraction of people who are applying who are men hovers around 30-35%, both to the left and the right. It doesn't look like there's a dramatic difference on the left and the right. Okay, so all of these things are reassuring and suggesting this cutoff method is likely to work. Okay, so given that then, you can turn to the treatment effect of attending FIU, which is shown simply by plotting mean quarterly earnings here around that cutoff, okay? And so what he's doing here is taking administrative data on earnings, this is from the unemployment insurance system, earnings of students who previously either attended FIU or didn't, and plotting earnings now around the GPA cutoff, 8 to 14 years after you graduated from high school, okay? And so what you can see here is, unlike in the previous charts that I was showing you, there's a very clear jump in earnings to the right of the cutoff relative to the left. And so the logic here is very simple. The guys to the right had a significantly higher chance of attending FIU than the people to the left. And we can, under the assumptions that we've been making, that those people are comparable on other dimensions, attribute the $372 jump in earnings at that point to the causal effect of attending Florida International University instead of your local community college, okay? So that's the simple logic of the regression discontinuity method. And we'll talk in more detail about exactly how you implement this in section, but basically, the idea is you just plot the outcomes versus the variable of interest that's driving this difference in admissions rates in this case, and then look for a jump at the relevant cutoff, okay? Any questions on how this works? Yeah.
Is this attending or graduating with a degree?
This is attending. So what he's doing here is, you actually don't want to do it conditional on graduating because that's partly an outcome. So he's basically saying, you by chance got into FIU and I didn't. Let's compare our earnings like 10 years later. Now, part of that might be driven by the fact that you actually graduated from FIU. Part of it might be driven by the fact that attending FIU for a couple of years, even if you didn't get a degree, perhaps has some causal effect. So then you can try to disentangle how much of it is a causal effect that actually comes from graduation versus not graduating. But conceptually, you need a different experiment in order to figure that out, right? You can't just compare the people who graduated versus the people who didn't. because they're not going to be comparable to each other. So for every additional kind of layer that you want to peel, you kind of need another source of variation, another quasi-experiment. That's a good question. Others? Okay, so what is the lesson from this? Okay, so you can see how in this particular case, you can estimate the causal effect of attending this one college very clearly. Ideally, what we would now do is do the same kind of thing for every college in the United States relative to every other college using either a regression discontinuity method or some other source of quasi-experimental variation. So as you can imagine, that's pretty hard to do in practice. First of all, because you need this kind of data for every college. And second, because it's hard to find those sorts of very clean cutoffs at many colleges. And so because that's basically infeasible in practice, what we're actually going to do, because we want estimates of the causal effect of attending every college in the US for our mobility analysis, is use earnings controlling for SAT scores and parent income as an estimate of each college's causal effect. So the idea is, I'm not going to be able to do this random assignment, quasi-random assignment thing at every college. Instead, what I'm going to do is take a set of kids who have the same SAT scores. So let's say like SAT scores of 1,400, parent income of say $80,000 a year. I'm going to find a set of kids who have those characteristics at Harvard and find a set of kids who have those characteristics who are going to say the University of Michigan. And I'm going to attribute any difference in earnings that I see on average between those two sets of kids to the causal effect of attending Harvard instead of attending Michigan. So I'm basically going to control for selection or differences in student background using data on students' SAT scores and their parent income. So that will work perfectly if the only dimension on which colleges are actually selecting students is based on SAT scores and parent income. Now, in practice, as you all know from applying to college, that's not exactly true. There are other things that matter. You might worry that there's selection on other dimensions, the kids who get into Harvard and have the same SAT scores as the kids who didn't get into Harvard and chose to go to some other place. They might be different on other dimensions. So this is not necessarily perfect, just to be clear. However, we think it does a pretty good job of capturing selection, and in particular, the way we judge that is by comparing the estimates you get from the SAT and parent income control method, where we're basically running a regression to get those estimates. We compare that to the quasi-experimental estimates you get at a place like Florida International University. So we can ask, Seth Zimmerman has estimated the causal effect of attending FIU relative to another college in a way that we think is pretty convincing. Does our scalable approach of controlling for SAT scores and parent income deliver an estimate pretty similar to what he found for FIU? If it does, then we feel more confident in our approach of just controlling for SAT scores and parent income. And it turns out, reassuringly, that the answer is actually yes, that if you just control for SAT scores and parent income, you get pretty close to what his causal effect estimate is, okay? So based on that and various other such comparisons we've done, we actually think that this really simple method of using earnings controlling for SAT scores and parent income is a decent first pass way of getting at the causal effects of each college in the US, okay? So that's what we're going to do. We're going to use these estimates to gauge the portion of the variation in earnings that is due to colleges' causal effects when we analyze impacts on mobility, okay? And so that's how we get the third key element that I was talking about in this exercise, is that there is some scope to increase low and middle income shares at highly selective colleges by admitting and enrolling more high achieving lower income students, okay? By finding these students who maybe, we don't know exactly what it is, right? These students are underrepresented at these colleges. It could be because they're not applying. It could be because they're not getting in, or it could be because they're not choosing to enroll even after they get in, right? Because they're worried about the cost or something else. Okay, so I now want to talk about how people are actually trying to tackle this problem in practice. So all of this, what I've been showing you is a little bit abstract. It's about hypothetical alternative policies to try to understand what is potentially feasible. And I want to make it much more concrete and talk about work that people are doing to actually change what happens on the ground. And in particular, that work is motivated by the fact that the underrepresentation of low-income students at these colleges that we've seen here, underrepresentation relative to their SAT scores, is partly driven by lower application rates of well-qualified low-income students. So this is a phenomenon that people call undermatching in the education literature. It's the idea that you should be matched given your SAT scores and your GPA. You can define your merit however you want. You should be matched to a really good college. But people have seen that kids from lower income backgrounds or middle income backgrounds tend not to apply to as good colleges for some reason. Now, the most obvious explanation that you might think of from an economics perspective for why low-income kids don't apply to good colleges, even if they could get in, is that maybe it's just about the cost of attending those colleges, right? Maybe it's too expensive for them. But that actually is not really the right explanation. And the way you can see that immediately is by looking at the costs of attending, average costs of attending different types of colleges in the US. So this data is breaking down the costs of attending college into two different components. So this is the red bars, the full bar is the sticker price. So this is kind of advertised tuition of attending Harvard. This is back in 2009-10. As you know, tuition's gone up significantly since that point. But the pattern is still going to hold the same. So the most competitive colleges, places like the Ivy Plus colleges, you see very high sticker price, much higher sticker price, for instance, than a public two-year college, for example, local community college that you could attend, right? Dramatically higher, like tens of thousands of dollars more. But in practice, for a kid from a low-income family, shown by the blue bar, the cost that you'd actually face taking financial aid into account if you were at the 20th percentile of the income distribution, you can see that that is dramatically lower. So while the sticker price in 2010 was something like $45,000 on average for the most competitive colleges, the actual out-of-cost expense was more like $7,000, right? And if you look at that blue bar, it's actually lower than the cost of going to some of the less competitive schools, possibly in some cases your local state school or certainly local private colleges, and often comparable actually to the cost of going to a local community college. So when you think about low and middle income students, especially after the recent expansions in financial aid at a number of institutions, cost by itself doesn't seem like the key barrier. Now, to be clear, at some of these more middle-ranked schools, cost still does remain a barrier because they don't have enough resources to provide financial aid for everyone. But at least at the very top of the distribution at the highly selective schools, it doesn't seem like it's just about cost. It's got to be about other things as well. Okay? So what is an alternative possibility? An alternative reason that kids might not be applying to these schools is that there's a lack of information or lack of sort of support in the application process for low-income students that limits their applications even when the tuition cost is low. So this is a hypothesis that was really made prominent in some well-known work by Caroline Hawksby at Stanford and Sarah Turner. And the idea here is that if you look at simple measures like how many guidance counselors are there per student in your school, for high-income kids, there's typically a lot of support in applying to college, or you have lots of friends who've applied to college, parents, et cetera, so you kind of know what the process looks like. For low-income kids, they tend to be much more, low-income kids tend to be much more disconnected from that sort of information. Okay, so that seems like a plausible hypothesis. So in a recent paper just put out a couple of months ago, which I think is a very nice and exciting study, Sue Donarski at the University of Michigan and her collaborators test this information hypothesis in a very rigorous way by running an experiment at the University of Michigan that exploits big data for targeting. So in my view, this paper is interesting not just because it fits with the topic we're talking about, but it illustrates, I think, the state of the art in terms of methodology in this area, which is to combine the power of big data from a diagnostic targeting perspective, and then the power of randomized experiments to actually learn about causal effects, all right? So what they do here is provide information about applying to University of Michigan to high-achieving students from low-income families. So they define high-achieving students as students who plausibly have some shot of getting into U of M. So in particular, you have to have a GPA above 3.3 and an SAT score above 1100. And then they define low-income families as kids growing up in families that are that have an income below about $50,000 a year. So that would put you like in the bottom 2 quintiles in the bar charts that we've been looking at. So the first thing you've got to do, and this is where the power of big data comes in, in order to do an intervention like this where you're trying to get a very particular set of kids to apply to your school, you need to be able to pick those kids out of all the children who are in Michigan, right? And so what they're able to do here is identify all the students who meet the criteria that they're after using administrative data from schools that they've collected that gives them information on the GPA of every student in the state of Michigan, the SAT score of every student in the state of Michigan. Importantly, in Michigan, it's mandatory now that you have to take the SAT, basically as when you're in high school. So it's not just optional, and so you end up having SAT score data for everyone, which is very useful for their purpose. And then third, you need some information on people's parental income. You would think that would be pretty hard to come by. Turns out you have a pretty good proxy in the school district data itself, which is eligibility for a free or reduced price lunch, which basically corresponds to having an income below $47,000 in Michigan. So schools need to do that in order to know who they should give a subsidized lunch to, and that basically provides a marker of income. So they're then able to put all that data together and identify 2,000 students each year in the state of Michigan who are low or middle income, high achieving students who meet their criteria, okay? And then they're gonna assign 50% of those students randomly to receive a treatment of additional information and support to apply to the University of Michigan that they designed. And so what does that treatment look like? It's a set of brochures that were sent to students, these 2,000 or 1,000 students who were randomly assigned to the treatment group that look like this. And so, they kind of advertise the University of Michigan. They show that you can attend with free tuition. Okay, so the attending with free tuition part is not a new thing in this experiment. You could actually have attended with free tuition with these qualifications even before this experiment. Everybody was eligible for that given their income cutoffs. But they're making that very clear. Students might not have known that before. And then they're doing a couple of other things, which you can see at the bottom here. They're waiving a bunch of fees that are often deterrents to application. So a fee waiver for the common application. They remind you that there's never a fee to fill out the FAFSA, and then a fee waiver for other information that they need to collect. So that's one aspect of the treatment. And then another important aspect of the treatment is that they reach out not just to the students, but also to the parents of the students. And they send them a personalized mailing where they say, since your child is an excellent student, we want to offer a potentially transformative college opportunity. If your son or daughter applies and is admitted to the University of Michigan, Ann Arbor, your child will be awarded the Hale Scholarship covering the entire cost of UM tuition and fees for 4 years. So up front, they're kind of guaranteeing you will not have to pay for college at all. And this is worth about $60,000, plus we will give you some other support, housing, textbooks, et cetera. So they're trying to make this very clear, target the right set of students, and make it as simple as possible, okay? And so the way I think about this, relating it back to the slightly more abstract discussion we were having earlier, they're basically saying, suppose we sort of try to move towards that SAT-based policy where we're trying to knock down all the barriers that low-income students might face, conditional on their SAT scores, of going to a highly selective school. This is a concrete way to try to operationalize that in one specific setting. And so what's the impact? So this is, simple control treatment comparison. 67% of the students in the treatment group applied to the University of Michigan. Only 26% of the students in the control group did. 32% of the students in the treatment group got into the University of Michigan, as compared to 15% in the control group. And 27% of the students in the treatment group are currently attending the University of Michigan. 12% of the students in the control group are. So they increased, through this simple, relatively low-cost mailing, the fraction of highly qualified students who attend the University of Michigan by about 15 percentage points. That's a pretty large increase given that the base rate is only 12%. So they doubled the rate of attending the University of Michigan in this group. And then furthermore, they show in the paper that it's not just that those students attend for 1 year and then find it too difficult or something and then drop out. The vast majority of these students continue to persist 2 years after the experimental intervention. The thing happened 2 years ago, so they can't look at graduation or other outcomes yet, but it's looking pretty good in terms of how the students are doing, the extra students are doing 2 years in. And furthermore, they show that it's not just that these students, would have attended some other excellent school, like they would have attended Harvard and now they're attending University of Michigan, which you might not think of as, like maybe you want to do that, maybe you don't, but that's not like what you're after. Actually, what they show is many of these students would have attended community colleges had they not attended University of Michigan. So they're actually having an impact on the number of students attending four-year colleges as a result of this simple treatment, okay? Questions on this study? Okay, so what is the lesson of that? Putting that all together, what this shows you, I think, is that removing cost and informational barriers for high-achieving low-income students can increase their access to highly selective colleges appreciably, right? I mean, it can increase the number of such students by a pretty significant number. Now, to be clear, I don't think that by in and of itself is the solution. So the way you can think about that is if you think about the magnitudes, it's impressive that they had that treatment effect. But remember, you're starting from a pool of 2,000 students, and you're increasing the fraction of students who attend the University of Michigan out of that 2,000 students by about 15%. So that's about 300 extra students per year that you're getting to attend the University of Michigan if you did it for all students in Michigan who would meet these criteria. So 300 students per year, I mean, that's a significant number of people. But in and of itself, it's not going to desegregate the higher education system. Michigan is still going to have a lot more high-income kids than lower-income kids, right? And so, more generally, my view on this is that we absolutely should be doing the types of things that Dynarski and collaborators are doing, and hopefully that's going to be scaled up pretty widely across the US because it's super low cost, and if a child is qualified to get into a great school, by all means you should try to make that possible. But I think the authors themselves would acknowledge that that is going to be insufficient to desegregate the higher ed system by itself. And the way that you can see that is, as I was showing you in the earlier slides, even if you completely somehow hypothetically eliminated all of these barriers and you just had pure SAT-based applications and admissions, anybody who had the right SAT score could come to Harvard. Even that extreme policy would not change low-income shares appreciably, especially at the really elite colleges like the Ivy League institutions. And so in order to have an impact on the diversity of the student body, especially at the low end at a place like Harvard, you need to do something else. You can't just rely on an SAT-based or meritocratic admissions policy. And so that brings us now to the second alternative admissions rule that I want to discuss. We talked about SAT-based admissions before. I now want to talk about a policy that is in some sense a bit more aggressive and tries to take more of a step in the direction of increasing the representation of low-income students, which we're going to call class-based affirmative action. And so the way we're going to implement that, it is exactly what it sounds like, affirmative action for kids from low-income families, all right? And the way we're going to implement that in our simulations and the data to see what it could do is to give an SAT test score boost to kids from low-income families. We're going to basically add something to the SAT scores of kids from low-income families and then replicate what we did under SAT-based admissions, and we're going to see how that plays out in the system. So now, obviously, the critical thing to figure out here is how much you're going to add to the SAT scores of kids from low-income families. The more you add, the bigger leg up they're going to have in terms of admissions, and the more low-income students you're going to have at a place like Harvard, right? So it's all about calibrating that boost in the right way. And we're going to calibrate the boost in the following way. So prior work has shown that legacy students, that is students whose parents attended the same college, get approximately a 170-point boost in terms of their SAT scores when they apply to college. Okay, so the way to think about how do you get that 170-point number, it's not that they're literally adding 170 points to your SAT score in the admissions office. It's if you look at the admissions rates of students, look at their full file, and look at how much your odds of getting in go up if your if your parents attended Harvard or attended Princeton, attended Yale, et cetera. The impact that that has on your probability of getting in is equivalent to the impact of having an additional 170 points on your SAT. Okay, so that's about what it's worth being a legacy student, all right? So we are gonna imagine, suppose it's feasible, apparently, to give that sort of boost to students from certain backgrounds. So imagine that we added 170 points to the SAT scores of low-income students instead of legacy students, okay, as a hypothetical policy. Again, not totally clear you want to do this, but just to understand what it would do, okay? And so here is the answer to that, shown by the third bar now, which is the class-based affirmative actions counterfactual on the same slide that I showed you before. So actual fraction of students at Ivy Plus institutions, about 3.5%, shifting to SAT-based admissions, hardly changes that. If you did class-based affirmative action, you just mechanically added 170 points to the SAT scores of kids from families from the bottom income quintile, and then you replicated the same SAT-based admissions policy that we looked at before, you can see that you would completely desegregate the higher education system in the US, meaning you would have as many low-income kids at Harvard as you do at selective colleges. In fact, you would have slightly more, and at other colleges. So that is, the higher education system would basically have like a uniform income distribution across all colleges. Okay, so this would have a dramatic effect in terms of the composition of the student body. And so the main takeaway from that simple exercise is that class-based affirmative action of a magnitude comparable to the implicit boost given to legacy students at present would have very significant impacts on segregation in the higher ed system. It would essentially desegregate the system relative to the very segregated starting point that we're at. Now, this policy, unlike the SAT-based admissions, which I think, moving to a system where qualified students get in at the same rate and attend at the same rate irrespective of their parent background, that seems pretty uncontroversial. The Dynarski type of intervention, hard to imagine why you would be opposed to that. Class-based affirmative action, that is much less clear in terms of whether you'd want to go in that direction. In particular, you are now admitting students with slightly weaker qualifications from lower income backgrounds, and that could potentially come at a cost for an institution like Harvard in terms of reducing selectivity and reducing average student performance. If your goal is to admit the best possible students, moving in this direction might take you away from that goal. So it's not unambiguously clear that you actually want to go in that direction. I'm going to come back to this issue at the end. But just to say, this is significantly different from the nature of the SAT-based admissions policies we talked about a second ago. Okay, so any questions on this? Yeah. 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 70% Asian, yep. Yeah, so, of course, race, it's very topical at the moment given the lawsuit and, it's of direct relevance thinking about these issues in the context of race, right? Race-based affirmative action has been, at colleges, has been a central issue in the US for a long time. We do not have the data right at the moment to do exactly the sort of analysis by race. But it's clear, and colleges have explicitly had race-based affirmative action for minority students for some time to try to address these types of issues. What we can say is that class-based affirmative action is a distinct thing from race-based affirmative action because there are a number of low-income students who would not get, who are not minorities and would not get affirmative action under the current system. You know, more broadly, you have similar sorts of issues, which you know just from kind of earlier work, that there's substantial racial segregation across higher education institutions in the US. And moving in this direction, you know, having affirmative action potentially counters some of that. And then there's a debate about whether you want to do that, whether that's legal and so forth, which, you know, I don't think this directly speaks to. But there are lots of parallels with the race issues, but they are, I think, distinct from the class-based affirmative action issues. Yeah. Oh, sorry. Let me take this one, I'll come back. Yeah. Go ahead, go ahead. Yeah. So you could get a bit of a flavor of that from some of the charts that I was showing you earlier that, remember how, let me just go back to it. So if we go back here, so if you go look at the middle income quintiles, if you just go to SAT-based admissions, that's already going to increase the representation of the middle income quintiles a little bit at places like Harvard. And then if you go to the full class-based affirmative action, the way we implement that in the middle class is we add 170 points for the bottom quintile, and then we linearly phase that out to bring it to 0 at the top. So like in the middle, you know, you're getting like an 85-point boost or something. And so then we show in the paper that that just makes it totally flat across the entire distribution, not just at the bottom, but in the middle as well, once you give that boost. Further back, yeah.
So if you would increase the amount of low-income students going, do you think that would reduce the amount of aid colleges are willing to give?
Yeah, I mean, all of this is, again, making this hypothetical assumption that you have the resources to do this sort of thing. And you're right, like you might not be able to afford it at some point. And so there's a balance you have to make between, you know, feasibility and, you know, what you'd ideally like to achieve if you want to go in this direction. So, you know, that illustrates, I think, a broader point with the exercises I'm showing you here. It comes back to the point that I've been emphasizing, that this is not intended to show you what is feasible, but what is possible, basically. Yeah. Yeah. So, yeah. Yeah. It's an excellent question. It is making that assumption. And, you know, you don't literally need the SAT score to be a perfect measure, but you need it to be, on average, a valid measure of the qualifications irrespective of your parent income, right? So there might be some kids who are even better qualified than their SAT score, which suggests among low-income families, among high-income families, but you need that error to be unrelated to parent income. Now, you gave an example, SAT prep, which could potentially violate that assumption, right? Where if the kids from high-income families have high SAT scores because they got a lot of SAT prep, and the kids from low-income families who got that, you know, same SAT score didn't have SAT prep, maybe in some sense their like true underlying qualifications are higher, right? I think that's the kind of example you had in mind. That would pose a problem. And so right now we're just running with the view that SATs reflect your qualifications. To get at that, you can actually try to study that directly by asking the following question. Because we have all of this data linked to the information from the tax records, we are now studying whether kids from low-income families who have a given SAT score actually end up doing better down the road than kids from high-income families who have the same SAT score, which is an empirical way to get at exactly your question. So I don't know the answer to that yet, but for now we're just using the SAT scores as a proxy for qualifications. Okay, so what I want to do next is wrap this up by coming back to the issue of mobility, okay? So we've been talking about the impacts of these alternative admissions rules on who shows up at the different colleges, the amount of segregation, number of low-income kids at Harvard, et cetera. But at the end of the day, kind of what we care about is not just integration, but outcomes. We care about how kids are doing in the long run. And so now we're going to do look at the same exact alternative admissions rules, but we're going to look at the impact not on parental income distributions across these colleges, but on mobility rates, on students' earnings outcomes. And we're going to measure mobility as the difference in the chance of reaching the top fifth of the income distribution for children who grow up in families in the bottom fifth versus the top fifth, okay? So as you know from before, kids from high-income families are much more likely to end up in the top fifth themselves than kids from low-income families. And what we're going to ask is, if we have these alternative admissions rules in the US, given all the data we have, how much would we be able to shrink that gap just by having students attend different colleges? Now, a critical assumption we're going to make in doing that analysis is that the causal effects of colleges that we've estimated using the method that I talked about at the very beginning of this lecture are unaffected by changes in the composition of the student body. So we're going to assume that if Harvard now has a lot more low and middle income students, as it would under class-based affirmative action, the causal effect of attending Harvard would remain the same. Now, that need not be true, right? It's possible that if you have a different set of students, either because of peer effects or because of changes in the type of teaching or something else, the causal effect of the college could itself change, but I'm going to ignore that for the time being. Okay, so what would this end up doing? So this is on the left bar here, you see the actual gap in your chance of reaching the top fifth of the income distribution between kids who grew up in poor families versus rich families. That actual gap is 22 percentage points. If we were to hypothetically switch to pure SAT-based admissions by doing a lot of stuff like the Dynarski type of thing, we could shrink that gap down to about 20 percentage points, a 10.5% reduction. So that's it's a pretty significant reduction, would have a meaningful impact. If you were to then go to class-based affirmative action, where you're actually kind of leaning in and trying to undo these differences actively, you would end up having a 25% reduction in the gap in your chances of reaching the top fifth. So you would really quite appreciably reduce the persistence of income across generations and increase low-income chances of climbing the income ladder simply by allocating students across colleges differently. And so then, to summarize, what I think you learned from the past couple of lectures is that the higher education system can in fact play a quite significant role in increasing social mobility, but it requires active effort to undo the disparities that emerge before college, okay? So if you had admissions based purely on academic qualifications as proxied for by SAT scores, that's kind of the easier thing to shift toward. That would reduce segregation across colleges, but have little impact at elite colleges in particular. And that's because pre-college differences in environment, we think, already create large gaps in achievement by the time you're applying to college, all the neighborhood stuff that we've talked about in the first few lectures. And as a result, you have relatively few students from low-income families who have sufficiently strong qualifications to get into the top colleges to begin with. But that doesn't mean that colleges like Harvard or other elite colleges can't do anything to counter those disparities, right? You can still actively counter those disparities and increase upward mobility for children from low-income backgrounds if you want to do so. In particular, if you move to a class-based affirmative action sort of policy, you could eliminate income segregation across colleges and increase mobility significantly. So I want to end with this last slide, which is assessing whether you actually want to do that. So unlike some of the other examples that we've discussed in this class, like the exposure to innovation stuff, here there may actually be an important trade-off between different principles that we care about. So on the one hand, we might value purely meritocratic admission to a place like Harvard, just admitting the kids with the best qualifications at the point of application, without worrying about why some kids had better qualifications than others. On the other hand, you might care about equality of opportunity and increasing social mobility, and you might want to give a leg up to low-income kids. The right thing to do, the optimal policy in the way economists would think about it, requires therefore some sort of value judgment on what colleges' goals should be, right? And economists typically view such value judgments as outside our field's domain and leave it to the general public to figure out. So it's kind of something for you to think about. Do you think Harvard should have purely meritocratic admissions or have class-based affirmative action in order to increase social mobility? I think that's an important question that has to be resolved to figure out the path forward. So I'll stop there.